For now, let's talk about graphing functions. So all functions can be displayed as graphs on a coordinate plane. So we use x and y when we're graphing. So here's y, here's x. Okay, so the function y equals x plus 1 can be graphed. So what we can do is we can make a table and we can say x and y. So we can say if x is 0, so we're plugging in the x here, then y is 1. If x is 1, 1 plus 1 is 2, y is 2. And if x is 2, 2 plus 1 is 3. So these would be the coordinates 0, 1, 1, 2, and 2, 3. So if we graph these, it would be, if this was a straight line, that would be the first point, then 1, 2, and 2, 3. And so if we did a straight line, it would go like this. So these points are on that line that go with this equation. So there are many more points that can keep going. So that's why the arrow is there. So like this point here, which is x is 1, 2, 3, -3, y is -2. Those should go in this equation. So if we say y, if we do the, if we do the x as -3 and then do the plus 1, that gives us y is -2, which were our 2 points. So this is correct that it goes on that line. So graphs can represent rates of function. So like time rates, like speed. So let me do, we can say distance over time, right? Speed as distance over time. And this is not straight in the slightest. So here's our x-axis and our y-axis. Okay, and so let's say somebody is doing a marathon run and they run, so some person runs at, let's see, 7 miles per hour, right? So then we can do, we can graph the distance d in miles that that person runs as a function of the number of hours, d hours h. So it can be written as the distance equals 7h, because it's 7 miles per hour. So now we can say for 1 hour, right, we can make a table. So we can do hour, distance, for 1 hour, the person goes 7 miles. For 2 hours, a person, so we would plug in 2. 7 times 2 is 14. For 3 hours, 7 times 3 is 21. So it would just continuously go up. So it'd be 1, I guess, let me, I don't know. Let me see if I can move the x-axis lower because it's all positive. So let's make this the x-axis, so x is 1, 2, 3, 4, 5, 6, 7. 1, 7, 2, 14, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So this is pretty steep. Right? The line. So the line for that function would look very steep like that. We can always adjust the scale if we need to. I did it as hours. We could change the scale to where, 1 mark is every 2 hours or something like that, so the graph is smaller. We can also graph curves and draw those. So like the function y equals x squared, let's see, here's x, y equals x squared. For the table, x, y, 0, squared, 0, so it'll be here. 1 squared is 1, 2 squared is 4, 3 squared is 9, 3, 4, 5, 6, 7, 8, 9, and then it would be 4 up to 16, so they're close here, and then it gets pretty steep again. But it is kind of curvy, here. I believe this one would go that way, but it would be like a reflection across the y-axis, so it would be more symmetrical. So we can do that, but this is graphing functions. Let me know if you have any questions